Bismillahirrahmanirrahim. In this session, we will discuss exercise 14.4, that is an exam exercise from differentiation part, and very important for IGCSE and O level student for additional mathematics course. And here we are going to discuss question number 1 first. So find the equation of the tangent to the curve. This is the curve, and we have to find the equation of tangent on this curve at the point on the curve where x is equal to 1. Show that the tangent bisects the line joining the point minus 216 and 12, 2. So we have to solve this equation, and let's first part. So this is the given curve y is equal to x cube minus ln x, and dy by dx of this is dy by dx is, first part is 3x square and ln x is 1 over x. At x is equal to 1, dy by dx is equal to 3 1 square and 1 over 1. So this is 2. So at dy by dx at x is equal to 1, dy by dx is 2. So at x is equal to 1, y is equal to at x is equal to 1, for this equation y1 value is obtained so this way. So this is y1, so in place of y1 we'll place this 1 here, this is here. So x1 is basically 1, so 1 is placed here, and y minus y1, that is 1, and that is the slope, the gradient is here, and x minus this is 1, so which is here. So this y is equal to 2x minus 1. So this is the equation of tangent on this curve at x is equal to 1. So this is the first part, and let's solve this second part. Show that the tangent bisects the line joining the point this and this. So we have to see that this bisects the line this. So this is the slope of these two lines. So this is the slope or gradient of these 2 points x1 y1 and x2 y2. On this we have this gradient is here, and this is minus 2, and this is y1 and y x1 y1 is placed here, and we have this equation. From this equation and from this curve, the tangent, this tangent which is 2x minus 1. So this is x minus 14, and this is tangent. From this we have obtained, so by the intersection of these two equations, so this is one line and this is another line, so they are intersecting, so we solve it simultaneously. We have obtained x equal to 5 and y is equal to 9 by equating, because they are equals to y, so they are equals to each other. So x is equal to 5 and y is equal to, in placing any one of the equation, we have placed it in this equation. Value of y, x here 5, and y is obtained as 9. So the bisecting point is 5 over 9. So the midpoint is x1 plus x2 upon 2, y1 plus y2 upon 2. So we will place this value x1 y1 place here, and we see that same point is obtained. So we have seen that these two lines are intersecting each other. So this is shown here. Since the bisecting point and the midpoint is the same, hence it is proved that the equation of tangent is bisecting the line joining the point 2, minus 2, 16 and 12, 2. So this is very important, and let's solve this question number 3. Variable x and y are related by the equation y is equal to 10 minus 4 sine square x, and where x is 0 to pi by 2. Given that x is increasing at a rate of 0.2 radians per second, find the corresponding rate of change of y when y is equal to 8. So this equation, let's solve this one. this is question number 5, where we have this y is equal to minus 4 sine square, and from 0 to pi by 2, and change in x is 0.2 radians per second. We have to find the change in delta y at y is equal to 8. So dy by dx first placed, and we have obtained this is this at y is equal to 8. So we'll place this y is equal to 8 here, and we'll find the value of x. So at y is equal to 8. So we'll place this in a given equation curve, and from where we have obtained the x value as 1 over under root 2, and this sine is basically pi by 4. So x is pi by 4, and from this pi by 4 we will place this pi by 4 here, and we will obtain pi by 4, and by placing pi by 4 we have obtained dy by dx is equal to minus 4. So dy by dx is equal to minus 4, and that dy by dx we have used it here. Delta y upon delta x is equal to dy by dx. In place of dy by dx we have used this minus 4 here. So minus 4 here, or the incremental change is 0.2 as given here in the problem. So that delta x is used as 0.2, and delta y is minus 0.8 radians per second. So this is question number 3. Let's solve question 5. Variable x and y are such that y is equal to e power 2x plus e power minus 2x. Find dy by dx. So we have to find dy by dx first by using the substitution u is equal to e power 2x. Find the value of y when dy by dx is equal to 3. So by using the substitution u is equal to e power 2x, find the value of y when dy by dx is equal to 3. This is the second part, and the third part, given that x is decreasing at a rate of 0.5 units per second, find the corresponding rate of change of y when x is equal to 1. So let's solve this question number 5. So we have given this y is equal to e power 2x, e power minus 2x. So dy by dx is obtained as this derivative, and this is dy by dx. This is part 1, and the part 2 we have to substitute. In place of this is u, so this is power minus, so 1 over u. So this is 3 is equal to, and dy by dx is obtained as 3. So dy by dx is 3. So this is 2, and this is u, and this is 1 over u, or u power inverse. So this is u over u. So by solving this u square and this u will change here, multiply on simplification 2u square minus 3u minus 2 on factorization. We have u minus 2, 2u plus 1 is equal to 0. U minus 2 is equal to 0. 2u plus 1 is equal to 0. If u minus 2 is equal to 0, then u is equal to 2. Or if 2u plus 1 is equal to 0, u is equal to minus 1 over 2. So if u is equal to 2, then y is equal to u 2 inverse, and this is 5 by 2. If u is equal to minus half, then y is equal to minus 5 upon 2. So this is part B, and in part C this incremental change is 0.5 units per second, and we have to find the change delta y. So at x is equal to 1. So dy by dx is obtained as this for x is equal to 1. So we'll place x in place of x, we will place 1. So this becomes e power 2u, this becomes e power minus 2u, and this is dy by dx, delta y it is delta y delta x, dy by dx, delta y is equal to dy by dx and delta x, and this is this delta x minus 0.5, so minus 0.5 here, and we'll just multiply with this one, so we'll have minus e power square minus e power minus 2, and by placing in place of this value of e, and we have obtained this minus 7.2 units per second change in y, with the minus 0.5 incremental change in or decremental change in x. So this is question number 5. Let's solve question number 7. A curve has equation y is equal to 2x sine x plus pi by 3. The curve passes through the point P pi by 2 comma a. Find in terms of pi the value of a. Using your value of a in part this, find the equation of the normal to the curve at P. So let's solve this question number 7. So we have this y is equal to 2x sine x plus pi by 3. So curve passing through the point pi by 2 comma a. So if this is passing through, so we'll place the value of x and y here. So by placing it appropriately, this a is here and this pi by 2 in place of x. So in place of x, we'll place this, and a is obtained as 4 pi by 3. On simplification, on taking the derivatives of this, and we have obtained dy by dx is equal to 2x cos x plus 2 sin x, and at x is equal to pi by 2, we have to place it here, and this is cos 2 pi by 2 is 0, and this is 2. So this gradient is obtained as 2. So in place of this gradient, so we have finding the normal equation. So in place of m, we will write this 2 inverse form minus 1 over 2, and x in place of x, and y1 is pi by 2 and 4 pi by 3 as we have obtained earlier. This is given pi by 2, and a in place of this, we have this 4 pi by 3. So we'll place this value x1 and y1 here correspondingly, and by simplification we have obtained this, and finally we have this 2y is equal to 19.pi by 6 minus x. So this is the simplified results, and in the next session we will solve some other questions.